So for this video, you will need your periodic table. So make sure you have that, and it should all be labeled from the first video that you watch. So this is ions and ionic compounds, part 2. So we want to review what ions are. Remember, ions are formed when elements lose or gain electrons. So we have either cations or anions. And our cations are the positive ones. So those are ones that have lost electrons. So we have magnesium with the 2+ there. So that'd be the cation. And the other one is lithium 1+. So that's the other cation that we have. So both of those have lost electrons. Lithium lost 1 and magnesium lost 2. And if you look at your periodic table, that would actually make sense, because remember, they want to become stable, and in order to become stable, they have to be like the noble gases. So if magnesium is element number 12, that means that the atom would have 12 electrons. Well, that's not stable. So it wants to have 8 valence electrons, and so it wants to become like neon. And in order to do that, it's going to give away 2 electrons. So it goes from 12 to 10. So it goes from 2 valence electrons to 8 valence electrons. So then it's going to be stable. Looking at lithium, lithium is number 3 on the periodic table. And so that wants to be like helium in order to be stable. So in order to do that, it needs to get rid of its 1 valence electron. So by becoming a lithium ion, it becomes stable. Then we have anions, and anions are negatively charged, which means they've gained electrons. So checking out O2-, which would be oxygen. So by gaining 2 electrons, oxygen would go from 6 valence electrons, because it's in group 16, to 8 valence electrons, because then it would be like neon. Then we have chlorine, Cl-. So chlorine can become stable by gaining 1 electron. So it goes from 7 valence electrons to 8 valence electrons, and then it'll be like the element argon. So the superscripts are going to tell us what the oxidation number is. And so this oxidation number up here is how many electrons are either lost, so that's going to be a positive cation, or gained, so that's going to be a negative anion, in order to become stable. And they want to become like the noble gases. So that's why magnesium will lose 2 electrons, because then it'll go from having 2 valence electrons to 8 valence electrons. That's why oxygen will gain 2 electrons, so that it goes from 6 to 8 valence electrons, because the noble gases have 8 valence electrons. Then we don't typically write the ones in here. You could write the ones in here for chlorine or lithium. You could write a -1 or 1-. It also doesn't really matter what the order is, but we don't always write the ones. So if you just see a minus or a plus, that would mean it either gained 1 electron, which would be plus, or it gained 1 electron, which would be minus. If you put the 1 in there, it's perfectly fine. Also, like I said, it doesn't matter if you write 2- or -2. Either one would be acceptable. Then monatomic ions are just one element. Mono meaning one, atomic meaning atom. So we just have one element involved. So we have the cations, which we reviewed, are the ones that lost electrons. So in order to identify this and differentiate between a cation and an atom, is we would have to put the positive symbol next to the chemical symbol. So by putting Na+, that tells you that it does not have 11 electrons, it has 10 electrons. So it's a stable ion. If you just put Na, that's the sodium atom. And so that would not be stable. That would be highly, highly reactive. And that would have 11 electrons. So the difference between sodium atoms and sodium ions is just 1 electron. A sodium ion has 1 less electron. So you have to identify that either in the chemical symbol or in the name. So instead of just calling it sodium, we'd have to call it a sodium ion. So you know that a sodium ion is something that has lost an electron. Whereas if you just say sodium, that would be the atom. So that has very different chemical properties. Sodium atoms are highly, highly reactive. Sodium ions are not reactive. We eat them all the time. So they're perfectly fine. So the difference of 1 electron makes a huge difference. And so we have to identify them. So if you just say sodium, that refers to the atom. Sodium ion refers to the ion. Calcium would be the same way. So you'd have to either indicate the oxidation number up here. If you just wrote Ca, that would refer to the atom, which for calcium would have 20 electrons. but the ion has 18 electrons, just like argon. So the ion is much more stable than the atom. So you have to identify that either with the chemical symbol or in the name, we just call it a calcium ion versus just saying calcium. For anions, those are ones that have gained electrons, so those are negatively charged. What we do to identify anions is we change the element's name, that suffix part, to IDE. So these are things you're fairly familiar with. So chlorine becomes chloride, oxygen becomes oxide. And so that's how we would change it in the name. We don't call it a chlorine ion or an oxide ion or oxygen ion. We call it oxide and chloride. So you know that if you hear that, those are ions, where if you hear chlorine, that's going to be the atom, and that would have 17 electrons. Chloride has 18 electrons, just like the element argon. Chloride is much more stable than chlorine. Chlorine kills you. Chloride is perfectly fine. And then in the chemical symbol, of course, we'd have to include the oxidation number so that we know that these are ions. If you just wrote Cl, that's the atom, but Cl minus is the ion. The same thing with oxygen, O2 minus is the ion, where just O would be the atom. All right, so if we look at our periodic table, so you have your periodic table out, what is the correct name for S2 minus? So S is sulfur, and it's going to gain 2 electrons because then it'll be like argon, and it'll have 8 valence electrons and be stable. And so we have to identify this as an ion, and so this is going to become sulfide. So that would be S2 minus would now become sulfide. So it's no longer sulfur, and because it is an anion, we changed the ending to match IDE. Then what is the correct name for Sr2 plus? So Sr is strontium, and it is number 38 on the periodic table. And so because it is an ion, we need to differentiate it from the strontium atom, and so we would call it a strontium ion. So cations, we just say that they're ions after it. We don't change the name, so this isn't a real thing. So we would just say that this is a strontium ion. Then the difference between chlorine and chloride. So the protons have to stay the same because they're still chlorine. We cannot change the protons. We're only changing the electrons for ions. And so chlorine is going to have 17 electrons. Chloride has 18 electrons. So chloride has 1 more electron, which makes it stable, which makes it safe to work with. And it's going to be something that is way more common that we work with. We don't work with chlorine, we work with chloride in the lab. Then what one is the correct formula for a cesium ion? So because it's an ion, we know that it's going to have either a positive or negative charge on it. And because cesium is in group 1, it's going to be a 1 plus, just because all of them are in group 1 are a 1 plus, because if they just lose 1 electron, then they become like the noble gas. So cesium would go from 55 electrons to 54 electrons and would be like xenon. So this one would be CS 1 plus. What about bromide? So when we hear bromide, we know that's going to be an anion, so it's going to be negative. And because it's in group 17, all of those halogens are -1. Because if it gains 1 electron, it'll be just like the noble gases. So bromine would go from 35 to 36. So always remember that electrons are like debt. The more you get, the more negative you are. So the less you have, the more positive you are. So when you gain electrons, you're going to become negative. When you lose electrons, you become positive. Then how many protons and electrons would sodium ion have? So Na plus. So the protons can't change. So sodium is number 11 on the periodic table. So it has to have 11 protons. And because it has that +1 charge, we know it's going to have 10 electrons, which is good because then it's going to be stable and it's going to be like neon. Now with the transition elements, on your periodic table, you identified your transition elements and then made yourself a little note to see the back of your periodic table, because these elements will form a variety of ions. You don't have to memorize them, you just have to know that you have to look at the back of your periodic table, and they're all listed on there for you. They are all cations, so they all lose electrons, they're all positive, And the ones that have multiple ions must use a Roman numeral. So all you have to do is look on the back of your periodic table and then figure out, okay, do I have more than one ion in the box? If you do, you use a Roman numeral. And that Roman numeral is going to tell you which ion it is. So you have some choices in some of those. So you have to figure out which one it would be. So with Fe2+ and Fe3+, so both of those are listed on the back of your periodic table. So we'd have to indicate which iron ion we're referring to. So Fe2+ would be called iron 2, and you can put the ion after it. You don't have to. And then Fe3+ would be iron 3. The Roman numeral tells us that it's an ion, but if you write iron 3 ion, it's not going to be marked wrong. So that would be perfectly fine. But otherwise, if you just want to shorten it up, you can just say it's iron 3. So by putting the Roman numeral there, you know that it's going to be an ion and it's going to lose 3 electrons. And this iron, iron 2, would lose 2 electrons. Now, we only do that for the ones that we've highlighted on the back of our periodic table, and the ones we've highlighted on the back of our periodic table are the ones that form more than one. They have more than one option. If they don't have more than one option, you do not use a Roman numeral. If you do write a Roman numeral in there, it will be marked wrong. So example is zinc. So zinc is always a 2+. There are no other choices for zinc. So you just call it a zinc ion. You can't just call it zinc. You have to call it a zinc ion so that you know it's got 28 electrons instead of 30 electrons. Then polyatomic ions, also located on the back of your periodic table. The polyatomic ions act as one, and so it's formed when you have 2 or more elements, and they combine together. They're covalently bonded together, and they form and act as a single ion. They could be cations or anions. Most of them are anions. Most of them are negative. And then that oxidation number, that charge, is going to apply to everything in there, not just one of the elements in there. So if we look at CO3, 2-, that 2- is applied to all 3 oxygens and the carbon. So it goes as a whole group. OH-, this minus charge, this 1- charge, is applied to both the oxygen and the hydrogen. To name these, it's super easy. You just look at the name on the back of your periodic table. That's it. So if you wanted to name CO3, 2-, it's just called a carbonate ion. If you want to name OH-, it's just called a hydroxide ion. NO3- is called a nitrate ion. All right, so how many protons and electrons would be in Ni+2? So that +2 tells you that you lost 2 electrons. Remember, electrons are like debt, so if you get rid of some, you get more in the positive. So nickel has 28 protons. You can't change that because its atomic number is 28, but now it's going to have 26 electrons, which allows it to have that positive 2 charge. Then the correct name of Cr3+. So we have to look, because it is a because it is a transition metal. We need to check the back of our periodic table to see, do we need to use Roman numerals? Okay, so you will need to use Roman numerals because chromium could be either a 2+, a 3+, or a 6+. So we would call this one chromium 3. So if you chose chromium ion, that would be marked wrong. If you called it chromium, that would be wrong because that's just the atom. And so chromium 3 would be the correct answer for that one. Which one of these is sulfate? So I'll give you a clue here. Whenever you hear ATE or ITE, that's a polyatomic ion. So IDEs are all the ones that we highlighted on the front of the periodic table. Those are all elements. ATE and ITE are all going to be polyatomics. So when we have sulfate, you have to look carefully at the spelling because sulfate is different than sulfite. So sulfate is going to be SO4 2-. Sulfite is SO3 2-. So you have to look to see which one it is, and this one is sulfate. All right, how many protons and electrons would cobalt 3 have? So this is going to be a transition metal because it does have the Roman numerals, and cobalt is one that forms multiple ions. And so our atomic number for cobalt is number 27, so which means it's going to have 27 protons. And then if it's a 3+, it lost 3 electrons. So therefore, it's going to have 24 electrons. And the correct name of N3-. So N3-. So N is nitrogen, and it's not a polyatomic ion. It's just nitrogen. And so that one we changed the ending because it is an anion. It's negatively charged. It's gained electrons. So what we need to do is we need to change that ending to IDE. So this would be called nitride. Nitrogen would just be N. There would be no charge on it. Nitrate ends in ATE, so that's a polyatomic ion that's on the back of your periodic table. So that's NO3 with a -1 charge, and nitrite is NO2 with a -1 charge. So nitride would be the correct name of N3-.